Okay, we're going to talk about composite functions, but first I'm going to readdress something about polynomials. One thing that I forgot to explicitly cover is that all of your exponents have to be greater than or equal to 0, and they have to be integers, okay? If not, then they're going to be, you'll see something like a rational function. Here's x to the negative 2 power, which is the same thing as 1 over x squared. That's a rational function, not a polynomial. That's when we have a ratio, okay? Even if it's a fraction, that would be, okay, that would not be a polynomial, okay? It's got to be, your exponents have to be integers greater than or equal to 0. All right, let's talk about composite functions. Work some examples. F composed of g, and our variable is x. This is the inside to the right of the little circle, which is the composition circle. G of x is my inside function, so I'll plug in a variable in it for x. I plug in an input, and then I run it through the function g of x. The output, which is g of x, is now my input for f. G composed of f is basically, f is the inside function now. Okay, so g is made up of f of x. So I plug in an input to x, run it through f of x. I get an output, and that output of f of x is the input for g. Okay? All right, so let's look at an example here. I want to do f composed of g, and our input is 1. Okay? So I'll go ahead. F of x is 2x minus 3. G of x is 4x. This is 2x squared minus 3, by the way. All right, so this one here is going to be f composed of g of 1. So 1 is my input, and let's plug, and this would be 4 times 1. Okay, so if I plug in, I'll just simplify this, thinking we should follow this. So 4 times 1 equals 4. Okay, so my output for f of x, f of 1 equals 4. I'm sorry. G of 1 equals 4. So that output is now my input for f, okay, equals 2. Here's my function for f, 2. 4 squared minus 3, which is 2 times 16 minus 3. That's going to be 32 minus 3 equals 29. Okay? So this would be 29. Okay? All right. Now let's work. Let's do g of f of 1. That's going to be, g is composed of f of 1, okay? So let's do f of 1 equals this function here. So that'll be 2, 1 squared minus 3, which is 2 times 1 minus 3 equals negative 1, okay? So f of 1 equals negative 1. That is now my input, okay, for g, okay? The output of f of 1 is negative 1, and that's the input for g, okay? So remember, g of x equals 4x. So g of x equals 4x, so we'll be equal 4 times negative 1, okay? 4 times, and that equals negative 4, okay? So just kind of doing the math here real quick. I plug in 1 here. 2 times 1 squared is 2, minus 3 is negative 1. That goes into this x, and 4 times negative 1 is negative 4. All right. And real quick, we're going to work f composed of f of negative 2. Okay. So basically, this will be f of negative 2 Okay, let's plug in let's plug in negative 2 for f and get an output, and then put that output back in for our input of f again. Okay, so I'm going to have f of x. Remember, f of x equals is 2x squared minus 3. So negative 2 squared minus 3 equals 2 times positive 4 minus 3 equals 5. That's 8 minus 3 is 5. All right, so now this 5 is my input now, okay, for the outer f's. We did f of negative 2. I got 5. Now I got to do, this means f of 5 essentially. Okay? So let's go do that again. 2 times 5 squared minus 3 equals 2 times 25 minus 3. That's 50 minus 3 equals 47. Okay? All right, so that's with numbers. Okay? Now let's talk about find the composite function and then the domain. Remember, polynomials, there's no restriction on the domain. I can put in all real numbers and my output's all real numbers, okay? Anytime I have a polynomial, okay? All right, now rational functions are different, okay? So now let's do f composed of g of x. Okay, so anywhere there's an x and f, I'm going to plug in g of x, okay? G of x is 2x plus 3, so let's write out f of x equals, it's going to be, I'm going to put a space anywhere there'd be an x squared plus 3 times x minus 1, okay? And basically, let me change this. So remember, x squared plus 3x minus 1, so anywhere there's an x, I'm going to take this function and plug it in there, okay? So my f of g of x is going to be, I'm going to plug in g of x here where all those x's, where the x's were, okay? So 2x plus 3 squared plus 3x, and x is going to be this g of x, 2x plus 3 minus 1. So notice, f composed of g of x is f, and the inside function is g of x. So anywhere there's an x here in my function f, that's where this is going to go. Okay? All right, so now I've got to square this. That'll be 2x plus 3 times 2x plus 3. If I FOIL this, that's 4x squared plus 6x plus 6x, and then 3 times 3 is plus 9. This will be 4x squared, 6x and 6x is plus 12x plus 9. Okay, so that's just this part right here. Now let's do 3 times this and 3 times that. 3 times 2x is going to be plus 6x, plus 9, and then minus 1. Here's my like terms. I've got 12x and 6x, that's 18x. I've got, and that's positive. I've got 4x squared, then I've got 9 plus 9 is 18 minus 1 is 17, plus 17, okay? And for this function, okay, for this type of function, notice the domain are all real numbers for this. And I can plug in anything for here, so I'm not concerned about this output. Remember, this output is my input here, but I don't care. This domain is all real numbers, so this can be anything. So there's no restriction. So my domain equals all real numbers, okay? All right, now, I got to hurry up here. Here's where it gets tricky, okay? F of x is 1 over x plus 2, and g of x is 4 over x minus 1, okay? So let's just talk about the domain real quick. Remember, the first function I'm going to deal with in f composed of g that's going to be f, and g of x is my inside function. So I got to worry first about my domain of this g of x. Okay? So right away, I've got a denominator and this can't be 0. If x minus 1 equals 0, that means x equals 1. So basically, x cannot be 1, right? 1 minus 1 is 0, okay? So right away in my domain, I have x can't be 1. Now, let's remember, this output of this entire function is going to be the input for x. Now look at x plus 2. I don't want that to be 0. I subtract 2 from both sides. If x equals negative 2, this denominator is 0, okay? So guess what? This output is this input. I don't want this output to be negative 2. So let's find out what will make that happen and then prohibit it. So 4 over x minus 1, I do not want it to be negative 2, okay? All right, so let's go ahead and solve, all right? I'm going to multiply both sides by x minus 1 and x minus 1. X minus 1 cancels out, so 4 will equal this. Negative 2 times x is negative 2x, and negative 2 times negative 1 is plus 2. I will subtract 2 from both sides. That'll be 2 equals negative 2x. And now I can solve for this. Obviously, what times negative 2 gets me 2? It'll be negative 1. So I'm going to divide by negative 2. And I'm going to get x by itself. 2 over negative 2 means that x equals negative 1. Okay? So if I have negative 1, 4 over negative 1 minus 1 is negative 2. 4 over negative 2 equals negative 2. That's what we don't want to have happen. So I basically solved for what x value makes negative 2, which is what we cannot have happen, right? That's negative 2 creates 0 in here, okay? So now, like I said, what do we do? We looked at what output, which is going to be the input here, cannot happen. Well, we don't want this output to be negative 2 because negative 2 plus 2 is 0. So we set this whole equation to negative 2 and solve for x. If x is negative 1, we get an output of negative 2, which creates this being 0. So we have two restrictions. This ends up being x cannot be negative 1. Okay? Negative 1 gives me negative 2, which makes that 0 in the denominator. So here's my restrictions. X can't be, for my domain, x cannot be 1 or negative 1. Okay? X cannot be 1 or negative 1. Okay? And finally, I'm just going to find the whole function here. This function here is going to go right here. So I will have 1 over, what do I plug in for x? I'm going to plug in 4 over x minus 1. 4 over x minus 1. And then plus 2. Okay, so anywhere there's an x, this g of x goes in for that. And that's 4. So I've got 4 over x minus 1 plus 2. Okay? All right? So what I'm going to do is, I'm going to multiply x minus 1, x minus 1. This is a numerator, and this basically is a numerator for this fraction that's in the denominator, right? So I'm going to multiply, this x minus 1 over x minus 1 is 1. So I'm not changing the value of the fraction. This is numerator, and this is in the denominator. However, in the denominator, let's focus on the denominator. This is a fraction, and we're going to multiply this distributive property times this and times this. So in my numerator, I'm going to get this times 1 is x minus 1. This times is 4 over x minus 1 cancels that out. And then I've got 2 times, and then this times this is 2 times x minus 1. Okay? All right, so let's distribute this. And I also have, what did I forget? I've got this times this. I still have the plus 4. Okay? So I have this x minus 1 times this gives me 4, plus this 2 times x minus 1. 2 times this x and 2 times negative 1 will be x minus 1 is my numerator, and this will be 2x minus 2 plus 4. Negative 2 plus 4 will give me this final equation of x minus 1 over 2x plus 2. Negative 2 plus 4 is the plus 2. That, my friends, was the F composite g of x. Okay, so remember, that's about it. That's 15 minutes. So we'll kind of go over that. Remember, when we have this F composite g of x would be the inside function. And anywhere there's an x in f of x, g of x goes there. And I plug that in. And I plug that in right here for x. All right, that's all I have.